Good morning, students. Before we start with today's session, let me give you some basic instructions about the assignments. As you all know that we have every day one assignment. So day one assignment, few of the students have not yet submitted. So it is asked to submit it by today itself. Okay. And even assignment number two, which was given yesterday, for it, the deadline is extended till today 6 p.m. Okay, so I hope both the assignments 1 and 2 will be submitted today itself. A very good morning and warm welcome to one and all. This today I welcome you all for this online machine learning workshop organized by Department of Information Technology and by SFIT alumni. Today we all know that this is the third day of the workshop, and let me introduce to you our today's resource person who will be conducting a hands-on session on learning with classification using Gaussian naive Bayes and support vector machine. Let me welcome our own alumni, Mr. Vivian Lobo. We all know him very well. He was associated with SFIT for a long period of time. He has completed his BE and ME from SFIT, wherein he was the top ranker for BE and ME both. So he also worked in SFIT for 1.5 years. He has 2 years of industry experience in Crimson Interactive Private Limited. And now currently he is working as an assistant professor in St. John College of Engineering and Management. He has actively participated in projects like multimedia-enabled virtual classroom for distance learning, study of diet sensors for health improvement, recapitalization of tweets using graph-based clustering. He also contributed 5 research papers in international journals and conferences. He has published a book titled Recapitalization of Tweets using graph-based clustering. He has practical knowledge in fields like Oracle, Java, NetBeans, VB.NET, ASP.NET, Weka, KNIME, Python, and many more. Vivian sir, we are very privileged to have you here for delivering today's session. Before we start, I have a small announcement for all the participants. All the participants who have joined this workshop, if you haven't joined Google Classroom yet, so please join the Google Classroom. Also join the WhatsApp group to get the latest updates regarding all the assignments and all your queries. And as we finish with the today's session, the feedback form link will be shared with you. So please submit your feedback form on time and also submit your today's assignment on time. This assignment and feedback form will also be recorded and your attendance will also be recorded, which will be considered for your certificates. In today's session, we need 2 different things to be installed. So I hope all the students have installed Google Colab and Jupyter Notebook. So please make note of it. If you haven't yet installed, you can go to the WhatsApp group, check the link and get it done. Okay, over to you, Vivian sir. All the best for the session.
Hello, Priyanka ma'am, am I audible?
Yes, sir.
Okay. Thank you so much for that warm welcome. Feels good again to be connected and being in touch with SFIT and meeting you all. So I hope students enjoy the session and we have a good time. Okay. So hello students. As ma'am has already introduced very well, so we'll start with the session. But before beginning the session, I'll just give you a gist as to what all things I'll cover and how I'll be going about. So I'll be covering two topics, that is learning with classification using Gaussian naive Bayes and support vector machines known as SVM. So I think the instructions were given, you require Jupyter Notebook and Google Colab. So I think most of them are familiar how Jupyter Notebook is used. And Google Colab, not to worry, I'll just show you. It's a real-time interpreter, so definitely it won't take much time. You don't require any installments. So we can directly move on to the hands-on. So I think, and there'll be an assignment as per the request from the college. So I have given the assignment. So I think it will be uploaded approximately at 2 p.m. The assignment is completely based on the hands-on, what will be taught in this 3 hours duration. So ensure that you listen carefully, and if you have any queries, you can post them on the chat box. So I think we are good to go. So I'll start with today's session. I hope my screen is visible.
Not yet.
Okay. Is it visible now?
It is visible.
Okay, okay, fine. All right, so I'll start with today's session. As you all know, the topic that I'll be covering is learning with classification using Gaussian naive Bayes. So before diving into the topic right away, I know we have a combination of third year and final year students of IT. So I'll give you a brief gist of what is machine learning, and we'll move ahead further. So machine learning, I think the topics have been quite well explained in the first two sessions of your workshop, but still I'll just give you a gist. So for those who aren't familiar, machine learning is nothing but a study that gives computers the ability to learn without being explicitly programmed. So you don't have to program your computer explicitly, it learns by itself. Okay. So the key factor over here is basically the ability to learn. So the computer itself or the system itself possesses the capabilities to learn by itself. And then this learning, which is done by the system, can be used to carry out several things. One among them is prediction. Okay, so this is basically just a overview, a high level overview, what machine learning means. So it is just the capability to learn without being explicitly programmed. So there is a very renowned definition that is given by one of the pioneers of machine learning, by Tom Mitchell. So he is of the opinion that a computer program is set to learn from experience with respect to some class of task. So a task is basically provided to a computer every time, and the system or the computer tries to learn from that task and tries to upgrade or update itself. And its performance is measured. If its performance for that particular task, it improves with experience, then that particular factor represents your machine learning. So a task is given, and every time whatever task is assigned, the system is able to learn by itself and improve at every stage. Then that is nothing but the ability to learn by the system by itself, which indirectly represents your machine learning. So there's a very famous example about the play checker game, where we have a system, and it's nothing but a task T, which represents to design a program to learn a play checker. Okay, so this is the task. You have to basically make the system learn how play checker can be played by the system. And every time when the system plays it, the performance is measured. Okay, that is nothing but the percentage of games won. And every time it improves its performance, the latest performance gets recorded. And that is nothing but it tries to improve again and again over a period of time, which is nothing but experience. That is playing against itself. So this is one of the most famous definitions of machine learning, as per Tom Mitchell, who is one of the pioneers who introduced this term, what is machine learning. Okay, so this slide basically focuses on a very high level overview. I will be basically taking a hands-on, so you might understand it more better when the hands-on is taken. So basically what happens over here is you have got a training data. Okay, so that data which is there, we have to use it in one of the machine learning algorithms, or we will feed that training data to the algorithm. The algorithm will learn. Okay, so learning which is there, it is basically of three types: supervised, unsupervised, and reinforcement learning. I'll explain to you in brief in the subsequent slides what are these different learnings. And through these learnings, the system will be able to train. And once the training is done, what is going to happen is you have basically made the algorithm understand what was your training data, and now the algorithm is completely ready to accept the new data, which is the input. And once that is received, the algorithm will be able to predict. So if it is able to predict accurately what is the actual output, then the model that you have built is successful, else the model remains unsuccessful. So this is a brief overview how machine learning works. So machine learning algorithm is trained using a trained data set to create a model. When a new input data is introduced to the algorithm, it makes the prediction on the basis of the model. So the prediction gets evaluated for accuracy, and if the accuracy is acceptable, then your algorithm gets deployed. So we will be seeing in the hands-on session what level of accuracy our algorithm attains. And if the accuracy is not acceptable, you train the model again and again so that you achieve an acceptable amount of accuracy. And how do you achieve it? With an augmented training data set. Augmented over here in this context is nothing but your large data set. Okay, so with a small data set, training your machine learning algorithm is not feasible and not advisable. But definitely if you have got a large data set, it will cover more instances and it will be able to provide better accuracy. So this flow is just a high level example, as to how many factors that are involved in the working of machine learning. I hope you all have understood this. So I'll just take you to the types, that is supervised, unsupervised, and reinforcement learning. This is already covered in your first session as per the schedule given. So supervised learning is nothing but task driven. So what happens in supervised learning is you are basically providing a label to your input data, and with that label you train your model. I'll explain to you in the subsequent slides. So one of the examples of supervised learning is predicting the next value. So supervised learning in real time you can use for stock market prediction. So you are basically monitoring the nature of the stocks for a week or so, and you are keen in investing in one of the shares. So basically what you will be doing is you will be checking whether that particular share has got a rise or a fall. So for a week's time, if that particular share has a constant rise, then definitely by applying one of the supervised machine learning techniques, you will be able to predict the next value, and you will be in a better position whether you want to invest in that particular share or not. The second one is unsupervised learning to identify clusters. Now, what happens in unsupervised learning is you do not provide a label to your data, and the model is not able to identify the label correctly. It will segregate the data into different clusters, but it will not be able to accurately tell you whether it belongs to that cluster or no. So that is one of the examples of unsupervised learning. We will be seeing the example. It's basically related to age groups. So you give input with respect to age, and depending upon certain features, you can apply one of the unsupervised machine learning techniques, for example, k-means, clustering, and you can segregate the data on the basis of age group. The last one is reinforcement learning. So learn from mistakes. So basically here we use a hit and a trial method, and from the mistakes we will be learning, and this is how the system gets developed. So as I told you all about supervised learning, you can see over here, you have got a known data set, which are your crispy apples. And we know the response also that these are apples. So basically this is the label. Okay, so you are basically giving this as an input to one of your machine learning algorithms, and you're telling the algorithm that this input is nothing but an apple. So when you provide a new data, once your algorithm is trained, the algorithm will be able to classify whether it is an apple or not. So this is nothing but supervised learning. So supervised learning is the feature when you can consider the learning is guided by a teacher. So we have a data set which is acting as a teacher, and its role is to train the machine or the model. Once the model gets trained, it can start making a prediction or decision when a new data is given. So here in my new data, if I do not give apple as an input, and if I give some another fruit, the model will be able to classify and tell that it is not an apple. Okay. So the computer is provided with example inputs that are labeled. So labeling of the data is very important under supervised learning. So these are some of the applications of supervised learning. That is, it is used for advertisement popularity, spam classification, and face recognition. So if you see over here, face recognition, what happened is features of mine have been basically taken by Facebook. And one of the faculties, that is Dakshata ma'am from computer department of SFIT, she had posted this photo, and I was not tagged, but because I was in her friend list and my features were constantly being monitored, it gave me a suggestion that so and so person has added a photo of you. So are you interested in tagging yourself or not? So these are some of the examples about supervised learning. So the features, which are nothing but the input, the system already knew, and the model got trained, and definitely it gave me a recommendation. That is, are you interested in tagging yourself or not? Same thing goes for spam classification. I'll elaborate this more when I take the applications under naive bias. So in spam classification also, there is something called as bag of words. So what happens in bag of words is that here basically there is a concept of tokenization, and through tokenization, we understand whether we need to classify it as spam or non-spam. So there will be some keywords, like if you get a keyword like a lottery or lucky draw, the model needs to be trained with those keywords in such a way that it identifies that it is a spam. Okay. Now coming to unsupervised learning technique, the data remains unlabeled. So the learning algorithm is left to find the commonalities among its input data. So if you can see over here, the input data which is there, it is a combination of different fruits. So you have got apples, you have got pears, you have got lemons for that matter. And this data set is basically provided to one of the algorithms, and the algorithm tries to find out the commonalities. And on the basis of that, it provides the clusters. So we don't give any kind of label. Okay, it's just an input which is given. Identifying the patterns or what are the common features, the algorithm will classify, that is, whether it belongs to that specific cluster or not. So this is unsupervised learning. Coming to applications, we have got recommender systems, buying habits, and grouping user logs. So these are some of the examples of unsupervised learning. So what happens in recommender systems is your online purchasing behavior. If I'm taking for an e-commerce system, your online purchasing behavior is constantly being monitored, and once that monitoring continues, you are trying to basically purchase something of a similar kind. Then before you search, you get a recommendation. Okay, so on your search behavior, the recommendation is given to you. Same thing goes for buying habits. So if you're frequently purchasing online a specific kind of a grocery to prepare a special dish, and one of the ingredients you have forgotten, so on the basis of the ingredients that you have already selected or the grocery that you have selected, the recommendation will be given to you. It may not happen at the first time, but if you are purchasing it from the same site constantly, you may get the recommendation. Same thing goes for grouping user logs. So what happens is in industry, when there is a technical issue, so normally we raise a ticket, okay, so that the technical assistant may come and resolve our issue. So for that, we need to basically raise a ticket where what I can say is you have to just specify what is your query. And what happens is, rather than the technical head segregating it as to whether it is the PC problem or the printer problem or whether it is a network issue, the segregation is done automatically, and the user logs which are there, they are classified depending upon what is the query raised. So if it's a PC problem, then all the PC complaints or restarting of PCs, they are grouped as one particular report and the others. So there is less of time that is wasted on analyzing the data, and you can just go and resolve the queries. So this is about unsupervised learning. The last one that you have got is reinforcement learning. It's basically your trial and hit method. So what we do is you have got an agent, and that agent over here is permitted to interact with the environment. Okay, and find out which is the best outcome. So your video games which are there, they normally follow this trend of reinforcement learning. So this concept originated basically from AI, artificial intelligence. So it is concerned with how the software agent is ought to take the action in an environment. So if he takes the correct action, there is a reward that is given to him. It would be either positive or negative. And on the basis of that reward, the model gets trained. So once again, it gets very easy to predict the new data that is presented. So once you have trained the model on the basis of the reward, it's easier to get correct result through reinforcement learning. So these are some of the examples. Your video games, I think you can see the game of Mario. So we have got an agent, we have got the environment, and we have got the action. Okay. So reinforcement learning concept can be related with your video games. There are industrial simulations and resource management. So in industrial simulations, I would like to give you an example of the aviation sector. When you are basically on-job training for being a pilot, so you are not given an attempt to basically fly for the first time. There is rigorous training taken place in a simulated environment. And as you all know, simulation is nothing but imitation of real world objects. So the feeling remains the same. And with that feeling, the training is given, and the pilot is basically gets the confidence, and then he or she is permitted to fly on air. So these are some of the applications of reinforcement learning. Coming to the actual part, this is the taxonomy of machine learning, where we have supervised, unsupervised, and reinforcement. So over here, basically, in today's session, I'll be taking naive Bayes and support vector machine, so which falls under classification. So I think in yesterday's class, regression was covered, specifically linear regression. So I will be covering classification, and naive Bayes is basically of three types: Bernoulli, Gaussian, as well as multinomial. So I'll focus mainly on Gaussian naive Bayes and support vector machine. All right. Okay. So before going on to these algorithms, you must know what is classification. So I think by now you might have got a gist as to what classification means. It's supervised learning means. So it's basically a type of supervised learning, and it specifies the class to which data elements belong. And it is best used when the output is finite and discrete. I'll give you an example of a data set. So basically, you have got different classes, okay? And from there are certain features given. The features have to be independent of each other to apply a classification algorithm. They cannot be dependent, and they have to remain finite. Okay, it predicts a class for an input variable as well. So basically, if you are giving an input, it will be able to give a prediction whether it belongs to that class or not. So we will be seeing this when we take a hands-on session on Gaussian naive Bayes. So coming to what is naive Bayes, it's one of the most simple and popular prediction algorithm, and nevertheless, it is also a powerful algorithm for predictive modeling. Okay, comes under the category of classification. And as we all know, classification and prediction play a very important role. I think everyone on this earth, I could say, are one way or the other using classification. Okay. So it's used for predictive analytics. So let's see what is this naive-Bayes algorithm and how did it originate, and how does it work, and how we can apply it in machine learning. So basically, naive-Bayes is originated, or it has its roots from machine learning algorithm. Am I audible? Or is it too loud?
Yes, sir, you are audible.
Okay, fine. Because I'm getting some chats.
You can lower some volume.
Okay, fine. So its roots are basically from a Bayes theorem. So classification technique is based on Bayes theorem with an assumption of independence among the predictors. So the prediction which is there, it is totally independent of the features which are given. So the features in a class are independent on each other. Let me take an example before that. So Bayes theorem basically is nothing but, I'll take through an example and then I'll get back to the definition. So all of you all can see this on your screen. You have got a deck of cards, and from that deck of cards, basically, I select a card, okay? And that card appears to be a king card, which belongs to the class heart. So the probability, as you can see, that it is a king card is 4 by 52, which is nothing but 1 by 13. Okay. Now, if some evidence is provided, and from that evidence, basically, I come to know that it is a face card. Okay. And it is a king. So the probability that it is a face card, given that it is a king, is 1. All right. And probability of it being a face card is 12 by 52. As you all know, in a standard deck of 52 cards, you have got 12 face cards. Now, if I want to find out the probability of it being a king, the card which is selected being a king is a face card, is nothing but the probability of a face card given that it is a king. This is based on some evidence. I'll come back to this. What is this term called? Each of these have got a specific term. Into probability of it being a king divided by the probability of a face card. So if you just substitute the values, probability of a face card given that it is a king is 1. Probability of it being a king is 1 by 13. And probability of it being a face card is 1. So when you substitute, you get the answer as 1 by 13. So this is nothing but the basic understanding of Bayes theorem. Now we can relate this basically how it is used in naive-Bayes. So we consider two events, A and B. Okay. So probability of an event A given that B occurs is nothing but probability of A intersection B divided by probability of B. This is your normal probability you might have studied in the lower semesters. And probability of B given that it is A is nothing but probability of B intersection A given that it is A. So as we all know, we can equate both of these intersections. So when you are equating, both are equal, that is A intersection B and B intersection A. So from there, you get probability of A given B is nothing but probability of B given A into probability of B upon probability of A. Now this is basically the base for your naive base. So I come back to this slide. Given a hypothesis H, okay, and evidence E, Bayes' theorem states that the relationship between the probability of hypothesis before getting the evidence. So if you remember the deck of 52 cards, I mentioned to you what is the probability of a face card given that it is a king. So that is the evidence. Okay. So between the probability of hypothesis being getting the evidence and the probability of hypothesis after getting the evidence. So it's P of H E is nothing but P of E H into P of H upon P of E. Okay. Fine. So as I told you, there are some terms with this. Basically, probability of hypothesis given that the evidence. Okay. So that is nothing but called as posterior probability. So posterior probability which is there, it is after getting the evidence. You have to find out the probability once the evidence is known. So that is nothing but prior probability, that is before getting the evidence. Okay, the likelihood, that is how probable is the evidence, divided by the marginal probability. So once you know the likelihood, and how will you get to know the likelihood is by the prior probability. And once the prior probability is known, the likelihood of the probability can be known along with the marginal probability. So this is the basic understanding of your Bayes theorem. Okay. So once we have understood this, why did I take this is basically we will be understanding naive-Bayes classification on one of the data sets. Okay. So that is basically a car theft data set. So you have got 10 rows or tuples for that matter, and you have got different labels, that is color, type, origin, and stolen. So if you all can see, stolen over here is your target label or class label. Okay. So if the color is red, type is sports, and origin is domestic, then in the records it was mentioned that this particular car is stolen. If the color is red, sports, and domestic, then the car is not stolen. So these are different permutations and combinations of one of the data sets. And on this particular data set, you have to apply naive Bayes classification. We'll be using the same data set to perform hands-on. So we have to train our model with this data set. And once we have trained our model with this data set, we will be giving an unseen sample. Okay. So the unseen sample is basically if the color is red, if its type is SUV, and if its origin is domestic. If you observe, this particular combination nowhere exists in your table. Okay. So for this particular data set, you will have to find out, or for this unseen sample, you will have to find out whether the car is stolen or not. Okay. So I'll just take you to the theoretical solution first, and we will do a hands-on on it. So if you see the probability of, we'll consider the class attribute, the target class which is stolen. So if you see in this data set, yes occurs 5 times. Total number of instances are 10. So probability of yes with respect to the class attribute is 5 by 10. Whereas no also occurs 5 times. So it is 5 by 10. Now using these, we have to find out the probability with respect to each of the classes, that is color, type, and origin. Okay. So I'll just give you an example of one of each. So if I'm considering the probability of the color of the car being red, and given that it is stolen, is going to be 3 by 5. It's very simple. How do you get this is, in your data set, you are going to check the frequency of occurrence of red with respect to yes. So red with respect to yes, this is once, this is twice, and the last column which is there, the last row, is the third case. So that is why you have got 3 by 5. Okay. So we will be considering all the features under this class. So red with respect to yes, yellow with respect to yes, sports with respect to yes, SUV with respect to yes, domestic with respect to yes, imported with respect to yes. And in a similar manner, we will be doing it for no also. So if you see, all the values have been calculated. Red with respect to yes, red with respect to no. This yes value is nothing but the value that you have obtained from here. Okay. So it will not be 10, it is going to be 5. Okay. So once these values have been calculated, we have been given the unseen sample. That is, if the color is red, if the origin is domestic, and if the type is SUV, sports utility vehicle, then you have to find out whether this particular tuple falls under the category of stolen, yes or no. So what we are going to do is, all the features with respect to yes will be multiplied with the overall probability of yes. So red, domestic and SUV with respect to yes, we know their probabilities. We will multiply overall with the final yes. So you get the answer as 0.024. In a similar manner, you will be doing it with respect to no. So you get the answer as 0.072. We will compare both these values and check which one is higher. So here in this case, 0.072 is greater than 0.024. So the unseen sample which is given to you, that is red, domestic and SUV, will get classified under stolen no category. So if we have got this particular feature, that is red, domestic and SUV, it will fall under the category no. Have you all understood this? You can reply in the chat. All right, I'm getting some yes. Fine. Okay, fine. So now what I'm going to do is, I'll be taking the same data set and giving y'all the hands-on. Okay. And I would also request y'all to do the hands-on. I'll share the data set in a while. So before going to the hands-on, just let me take a few industrial applications of naive Bayes algorithm. The algorithm is basically used for news categorization. Yeah, there is some student asking, sir, what if yes and no have the same value? In that, there is something called as, if they are having the same value, then there is something called, there is another method where we basically apply something further than naive Bayes. So that is error correction method that is applied. Okay. So what we will be doing is, we will be going one step further, and we will be trying to add another tuple in that case and classify whether it is yes or no. We'll see that case when we are taking the hands-on. Okay. So the industrial use of naive Bayes is, first thing is news categorization. So yeah, a lot of data is available on the web, and it is very important that we categorize the news. Okay, so for that, web crawlers are used to extract the text from the web pages. And once the information is extracted, the companies use the concept of tokenization. And these tokens which are there, they help in categorizing the news. So whether it is a sports news, whether it is your travel and lifestyle, whether it is stock market, politics, so on and so forth. So before applying tokenization, there is some step called as stop word removal. This basically happens when you are doing the pre-processing of your text. So stop words are basically all your full stops, commas, periods. You have got all the special characters, they are removed, and then tokens are basically given to your text. And then on the basis of certain keywords, you categorize your news. So this is one of the industrial applications of naive Bayes. The next one is spam filtering. So spam filtering, as I told you all initially under the applications, it uses the concept of bag of words feature to identify whether a particular email is a spam or not. Here once again, the concept of tokens are used. So as I told you initially that if keywords like lottery or lucky draw are present, then definitely there is a high probability that it should be classified under a spam category. And this concept took its roots or started in the early 1990s. Okay, so initially if you go to see, if you check your Gmail spam folders, the number of spam emails that you get on a monthly basis will not be more than 9 or 10. Initially, there were many spams. Okay, on a monthly basis, you could get 45 to 50. But as and when Gmail has worked on it and achieved very good accuracy, so on an average, if you go to see, not more than 9 to 10 spam messages are there. Okay, so spam filtering is done where naive-based classification is used. You have got object and face recognition. So the features which are there are basically extracted, and with the help of these extracted features, naive base is applied and we categorize and classify. Okay, so object and face recognition can be done through naive base. Medical data. So there is voluminous amount of medical data that is available, and with this data it is very important. We want to diagnose a disease, so definitely we can use naive Bayes for diagnosis of any disease through medical data. Weather prediction, still we are working on this area because we are not able to get accurate weather prediction. The research area is still on. And as you all know, weather prediction is very important if I'm considering for agriculture, because if the rains are predicted properly, then definitely the farming can be done. So weather prediction is one of the areas where accuracy is still a problem, and the work is still in progress. So here naive Bayes is used. Coming to the types, as I told you, we have Gaussian, multinomial, and Bernoulli. And sticking to the session, I'll be only taking Gaussian naive Bayes, but you can also try Bernoulli and multinomial when I'll take the hands-on. So Gaussian naive Bayes is basically for making predictions where the features are distributed. You have got even features. Okay, so that is the case where Gaussian will be used. So your car data set, which is their car theft data set, we can apply Gaussian naive Bayes. Bernoulli is basically used for binary features. Okay, so if you have got zeros and ones, okay, or if you have got true or false, or if you have got male females, so Bernoulli is one of the best Bernoulli naive Bayes is one of the best techniques that you can use. Multinomial is good for both, that is categorical and continuous. Okay, basically it is used under word counts. So when we apply document summarization, so in that case, multi-nominal which is there is the apt. So it depends on which data set you are selecting, and on the basis of that data set, you will select the algorithm, the classification algorithm. So I think we'll move on to the hands-on. So we will be taking classification, naive Bayes classification on Google Colab. So for those who are not able to jump into Google Colab, what you can do is just go on Google and type Google Colab, and you can log in with your college ID, which is provided. So please do that, all of y'all. I'll wait for a minute. And once you'll have done that, you can just put a yes in the chat box so that I can proceed further.
So there was a doubt in this chat box regarding if yes and no have the same value, what do you consider?
Yeah, I did answer that, ma'am.
Okay, sorry for that.
Okay, so I guess I'm getting a majority of yes. So y'all are basically through to go through Google Colab. So Google Colab is one of the notebooks provided by Google, where you don't require any prerequisites for installation. Everything is done in a real-time environment, and you can execute your Python codes easily. Okay, so what we'll be doing is I'll be sharing the data set with you all. But before sharing the data set, I want you all to import these two libraries. That is, import NumPy as NP and import pandas as PD. You can type these. For those who are not familiar with these libraries, NumPy is basically a library for scientific computing in Python. So it provides a high performance multi-dimensional array objects. So any computing that you have to perform requires NumPy, and pandas is used for analyzing your data. Okay, if you want to visualize your data, which we will be seeing in SVM, you will have to import matplot as well as Seaborn or Bokeh. There are different libraries available. So as of now, I require only NumPy and pandas. So have you all imported these libraries? Once you all have done that, you are supposed to click on Shift Enter. And I think you can see the cell is getting executed. We will be doing cell by cell execution. It might take a time. You can see over here on top, it is basically setting up the environment. And I'm using Python 3, Google Compute Backend Engine. So once that is done, yeah, importing part is you have to basically import these two libraries, which you can see on your screen. That is, import NumPy as NP and import pandas as PD. These are the two libraries. So NumPy is basically used for your uh, computing purpose, and pandas is for data analysis. All right. So I think good to go. The first cell has been executed by you all. Can I get a few more yes on the chat if you all have done? Perfect. So now we will be importing the data set. So I'll be using the car data set. So what I'm doing is I'll post this link on your chat. You can download the data set from there. So I've posted the link for the car data set, requesting you to download this data set. please download this car data set. It is a .csv file. Okay, so if you have downloaded, on the left hand side, you may see the option to import, upload the file. So you can go click on the upload option and you can upload the data set. So even I shall do that. You all can do it simultaneously with me. So the car data set needs to be uploaded on Google Colab. So as you can see, I've successfully uploaded the data set. If you all have done, please give a thumbs up or a yes so that I can proceed further. Perfect. So once you have done that, we will be reading this CSV file. So the command is pd.read_CSV, and within your single inverted commas, this car is nothing but the file name. Okay. So data is just a variable for that matter, is equal to pd.read_CSV car.csv. Once that is done, we want to know the shape of the data. Shape of the data basically means the link is already provided in the chat, Stanley. You can download that and you can upload it on Colab. Make sure you're paying attention because the assignments are based on what hands-on I'm taking. Okay, you want me to resend? I'll resend it once again. Yeah, how to upload? On the left hand side of your Google Colab, you may see this folder, right? Click on the folder and click on upload. So once you click on upload, you can directly upload the CSV file. Upload, click on upload. You may upload the CSV file, and once you have successfully uploaded, you can see the file over here. Is it done? Okay. Now, this is the command that you are basically going to type to read your CSV file. As I told you, we require pandas. So data is equal to your pd.read_CSV. So for data analysis, we are using pandas. If pandas library is not imported, it will definitely give you an error. And it will ask you to import pandas library. Now data.shape is nothing but we want to know what are the number of rows and columns in your data set. Okay. So we want to check out. So we'll type print data.shape. So you can print data.shape, and once you have done that, you can click on execute. So once you execute, it will show you 10,5. Basically 10 represents the number of columns that you have, number of rows that you have, and 5 represents the number of columns. Okay. And if you want to check the data set, the command that you can type is data.head 10. 10 basically represents the first 10 rows. Okay. This number is up to you. You can even just type 1 for that matter. So if you see, you can just see the first row where you have got serial number, color, type, origin, and stolen. Okay. If you want to check, by default, if you don't put any value, it will show you the first 5 entries. Okay, it will show you the first 5 entries. And if you want to know the remaining entries till what is the entire length of your data set, you can just type data.tail. So once that is done, it will show you the remaining 5 entries from the bottom. I'll repeat, you load your CSV file and you want to check what is the nature of that file. That is number of rows and columns. So we'll type data.shape. So dot shape helps in identifying what is the nature of the table. And you want to know what are the total number of rows or columns in your data set. So if you want to know the total number of rows, data.head function. Okay. So I'm mentioning 10 over here. You can mention anything of your choice. You can see how many are there. So I have got 10 over here. If you want to know the last column, the last 5 columns, 5 rows, it will show you the last 5 rows. Okay, head or tail. Good to go, all of y'all. Any queries? Cool. Now, what you're supposed to do is you have to assign features and label variables. Now, if you see over here, we cannot give, these are basically text or strings for that matter. We cannot use these terms as it is. That is red, yellow, sports, domestic, yes and no. We will have to convert this, okay? Features and label variables. So for that, basically, we will have to do pre-processing. So for pre-processing, basically, we will have to write this command. That is, from sklearn library, you will import the module pre-processing. So all of y'all, please type this command from sklearn import pre-processing. Have you all done that? From sklearn import pre-processing. Once you'll have done, you can just give a thumbs up or a nod so that I'm aware. Okay, you'll have to type, Keith, some commands which are lengthy. I'll paste it on the chat. The ones which are quite simple, we'll go about with it. So under pre-processing, we will be calling label encoder. Okay. So label encoder is nothing but it encodes the label with a value between 0 and n classes minus 1. That is 0 to n minus 1, where n is the number of distinct labels. So if you go to see over here, color, type, origin, and stolen are basically the labels. Okay. And below these labels, you have got your features. Okay. So the next command is pre-processing dot label encoder. And we assign this particular to a variable LE. So please execute this. Make sure every line of code that you are typing, you are performing the cell by cell execution. So LE is equal to pre-processing dot label encoder. So now what we are going to do is all these features will be converted into zeros and ones. Now you have to basically convert these strings into numbers. Okay. So what you're going to do is, now as we all see this, color has got these features, that is red, yellow, and so on. So you will have to first type this. So without wasting much time, I'll share this on your chat. So you can type this, copy paste the command. It's nothing but these values from the data set that I've taken. Yeah, it is after sklearn. I have written it initially. So after sklearn import preprocessing, and when you have called le is equal to preprocessing.label encoder, you are supposed to execute that command. So what I'll do is, to avoid confusion, I'll put it over here. Okay. So once you have written this, you are going to call the fit underscore transform function. So this basically will convert your string labels into numbers. So le is equal to fit underscore transform. And this color is nothing but this variable that you have taken. And this entire thing, you will assign it to another variable, which is encoded. So it is color underscore encoded. Once you have done that, you will have to execute. So shift enter, or you can click on the play. Both are fine for execution. Once you have done that, you can check whether the transformation has been done successfully or not. So you will print color underscore encoded. So once you do that, you can see over here, this red is basically assigned the value 0 by the label encoder. Okay, you want me to reduce the font size? Perfect. This I've already given in the chat box. You need not type. You can directly copy paste it from the chat box. You might have not executed this cell. Ignatius Francis, le is equal to preprocessing.label encoder. Make sure you have to execute each of the cells. Otherwise, it will give you an error. So once you have done, you can print and you can check red is assigned the value. You have missed fit underscore transform. Just check over here what variable you are using. So once you have done that, you can print and check. So 0 implies red and yellow implies 1. Okay. If you have done till here, plus just let me know. Just give me a yes or a thumbs up. Perfect. So what you can do is you have to do it for the other classes as well. So I'll paste this on your chat so that you need not type. It will save time. So now we'll be doing it for type, origin, and stolen. The procedure will remain the same. That is, le is equal to preprocessing.label encoder. And now what you are going to do is, you will call the fit transform function, that is fit underscore transform, and now transform your type label. You have to simply copy paste. You have done it for color. Change the name of the variables for type, origin, and stolen. And once you have transformed it, you will take another variable origin underscore encoded is equal to le.fit underscore transform type. So what will happen in that case is the type which is there, it will get transformed. So if you want to see whether type has got transformed or no, you will type over here print type underscore encoded. So you can see over here for type we had got sports and SUV. So sports, the transformation is done to 1 and SUV it is done to 0. So you can see at the end it is sports and that is why it is showing over here 1. Ignatius is getting an error. Just check the code, Ignatius. Are you calling preprocessing.label encoder properly? And have you executed this particular cell from sklearn import preprocessing? Have you executed the initial cells, that is pandas and this? Just run the cells. Have you all done it for type, students? If you all have done it for type, I'll request you to do it for origin. So origin, if you see over here, we have domestic and imported. So domestic which is there is basically showing as 1 and imported is given the value 0. Yes, sure, Ignatius. Just run all over and check. You have to do it for stolen also. So please do it for stolen. Stolen we have got yes and no. This is the pre-processing step before applying prediction. So we are basically transforming. So this is just an additional step to show you all, that is color type origin. I have successfully transformed. How did we get for stolen? The same procedure has to be applied for stolen. That is le.fit underscore transform. You will use over here stolen. Type origin. This should be stolen over here. Okay, the way how you did it for color, in the same way you have to do it for others. So we have done it for color as I showed you all. The same thing goes for type. The same thing goes for origin. This is an additional cell actually. I'll just delete it. So type origin and stolen. This should be origin. So color, type, origin, stolen. Okay. Is it done till here? Okay, fine. So you can check the encoded ones for type, origin, as well as for stolen. Okay. Now what we have to do is we have to basically map the stolen class with each of these, that is color, type, and origin, because stolen is nothing but your target class. Okay. So what we are going to do is the first class is color. So color underscore encoded is equal to le.fit transform color. Okay. This will now be compared with, you're going to use a label. Your label is nothing but the class label. And in this label, you are going to call the fit transform stolen. So what you're doing, you are comparing this stolen with color. Okay, so stolen with color. So what is happening? Color and stolen have been checked. So red is for 0, yellow is for 1. Yes, which is there, it is basically 1, and no is 0. Once you have done that, you need to execute. If there are more than 2 colors, it will take the value 0, 1, 2, 3, 4, so on and so forth. Harsh, is it clear? Step 27 is nothing but the class, target class stolen is now compared with each of the other classes. And because we are assigning this label is basically required for training. We will be training our model. Have you all done till here? If you all have done till here, you can just put a thumbs up or a yes. In a similar manner, you will be doing it for the remaining 2 classes, that is type and origin. Only this particular line will change. Instead of color, it will be type, and here it will be type, and here you will be calling type underscore encoded. And then execute it. So type with respect to stolen. And similarly, you will be doing it origin with respect to stolen. If you all have done till here, you can just put a thumbs up. I'll wait for a minute. Don't forget to execute the cells. Ketki has done. Tulika has done. Okay, so I'm getting a few more yes. I'll wait for half a minute or so. Okay, so if y'all have done till here, now we will combine all the three into a single list of tuple, that is color, type, and origin. So what are we going to do is we will be using the merge function. So def merge, you will be calling all the three transformed values, that is color underscore encoded, type underscore encoded, origin underscore encoded. Don't forget to put the semicolon, otherwise you will get an error. And what are we going to do is we want to view it as a single tuple. So we will first zip it. So zip, within the zip function, you will be putting color encoded, type encoded, and origin encoded. And we want to view it as a tuple. So then we will call it as a tuple and assign it to merged underscore list. And we'll return merged underscore list. So once you do this and when you execute, you want to check out whether the tuple is formed or no. So we will be printing this entire color, type, and origin encoded. So can you see over here? So basically what has happened, we can see row wise our data. So 0 is for red because it is for color. 1 is basically, I think, your type, and which is, I think it is SUV, and 0 is nothing but domestic. Okay, so you can see in a row wise manner. Okay, so somebody is requesting for the code. I'll paste this code on chat. I've pasted it. Make sure whatever you put in hash is nothing but your comments. You don't require that. I've just added for your clarity.
नंतर पेते का नाही शा.
How many of y'all have done till here? Okay, you need the code about this. I'll paste it for origin. You will have to do it for the others. Have you all done this till here? Okay, Samarth requires a minute. Okay, so this is your pre-processing step. Now, once pre-processing is done, we will apply Gaussian naive Bayes. So your sklearn library has got the Gaussian naive Bayes model inbuilt in itself. So what you are going to do is you will type from sklearn dot naive underscore Bayes import the model Gaussian NB. Please type this. from sklearn.knife_bias import Gaussian NB. Okay, Stanley has done. Now, this particular model which is there, Gaussian NB, okay, we need to basically create a classifier. So we'll assign it to model. Model is equal to Gaussian NB. Okay, as I told you, there is Bernoulli as well as multinomial. So basically for Bernoulli, you will have to write Bernoulli NB. And for multinomial NB, it depends upon the data set. Okay, the nature of the data set. So for car theft, we are taking Gaussian naive Bayes. So now once you have done this, can I get a few more yes if you all have done, so that I can teach you how we can do the training? All right. So how do you train the model is basically with the help of the fit function. So what are you going to do is, within your fit function, you are basically going to include all the three labels. That is color encoded, type encoded, and origin encoded. And you will compare it with the label. This label is nothing but the stolen one, where we had used. If you all remember, we had used this particular label stolen, and we compared it with respect to color, type, and origin. So what are we going to do is, for training the model, we are going to use model.fit. We will be comparing all the three encoded classes with the stolen class. Module not found, you might have not executed the previous cell. Please don't forget to execute the previous cells. If you don't execute the previous cells, you will get an error. Somebody is requesting for the code. I'll just paste this code on tab on your chat. If you all have done till here, you can just give me a yes or a thumbs up so that I can proceed. So now if you see over here, when you execute this particular code, Gaussian knife Bayes has been used for training this particular data set. So priors is equal to none. It basically implies there was no prior training done on this particular data set. Okay, and there is something called as variable smoothing, and its value is 1 e raised to minus 0.9. So priors are basically nothing but whether you have been trained previously with this data set or no. Okay, and variable underscore smoothing, it always has got a default value. Okay, so by default, you will get this after execution. Have you all done till here? Okay. Now we have trained our model and we are supposed to perform the prediction. So what are we going to do? We are going to use the predict function. So model.predict, you can see over here, I have included 001. Okay. Now what does this 001 mean? If you remember, when I took the example over here, we were interested in the unseen sample, that is red, SUV, and domestic. And red, our system has taken the value as 0. SUV, the system has said 0. And domestic, we have got the value as 1. Okay. So this is the unseen sample values that I am passing in my trained model. So model.predict 0, 0, 1. And once you have passed this inside your predict function, you can print the predicted value which is stored here. Once you execute, you get the answer as 0. Now this 0, what does it mean? This 0 is related to your stolen class. Yes, someone is saying to repeat. What I'm saying is, once you have trained the model, okay, what are you going to do is, you have to find out the prediction for an unseen sample. Okay, so you must be wondering, what is this 0, 0, 1? 0 is nothing but the unseen sample what a particular system has given. So if you see over here, red is 0. We have to find out red, SUV and domestic. Your SUV value which is there is 0 and your domestic value which is there is 1. So we are passing the unseen sample over here. This depends upon for which sample you want to find out. Okay, so I am taking red, domestic and SUV, that is why it is 0, 0, 1. And once that is done, with respect to this, it will give you the predicted value for the class attribute stolen. So it is giving the value as 0. So what does that mean? When the color is red, when the type which is there, it is your domestic SUV, and when the origin which is there, it is domestic, the car is not stolen. That is why it says as 0. Is it clear? Any questions for Gaussian knife base? So you can check it for any values. For example, if it's yellow, if the unseen sample was yellow, and here I keep 0 as it is and 1 as it is, so in that case, it's giving a value 0. If I keep all three 1 for that matter, it's giving 1. That means if the color is yellow, if the origin is something else that is other than SUV, and if the type is imported, then it will give you the value as 1. Smoothening, yeah. Basically, what does it do is that features which are there, whatever features we have taken, different features under different labels. That is, for color, we have got yellow and red. For origin, we have got domestic and imported, and for type, SUV and sports. So that are used for the calculations. So the default value that we prefer to keep is your 1 e raised to minus 9. I hope you all have understood till here. You can change the smoothing variable if you have got a previous, you have used this data set previously to train. Gaussian knife base object has no attribute predicted. This is a question from Lavia. Have you not used, you might have not executed the previous cell, or check whether these are used consistently. So I hope you all have understood with Gaussian knife base. Any doubts? Okay, Rutuja has no doubts. Can I get a few more responses so that I can proceed forward? Okay, cool. So for your first assignment, what has been done is I have given you all another data set, which is for a tennis data set. You will have to follow the same procedure, and you have to basically find out, depending on a given unseen sample, whether it is advisable to play tennis or no. Don't worry about the code. Along with my slides, I'm also providing the Google Colab page where the code is made available. You will have to only modify your data set. The link for the tennis data set is provided in your assignment, and that assignment will be shared with you at 2 o'clock. All right? Okay. So I'll move to the next topic. The next topic that is there is support vector machine. So I'll take you to the next topic, that is support vector machine. Yes, definitely Gaussian naive Bayes can be used for larger data sets. You can have lakhs and lakhs of records, and you can use that, not a problem. Okay, can I proceed to support vector machine? All right. So we have seen under classification, which is a supervised learning technique, where we have executed Gaussian naive Bayes. I'll take you through the next technique, that is SVM, one of the prominent algorithms or techniques you can say under supervised learning, that is support vector machine. Let me make it very clear to you that support vector machine is not used for prediction. Okay, it's basically used for improving the performance of your algorithm. Okay, so it will improve the performance of your algorithm, and we'll see how. So before going on to the hands-on, I'll take you through a small gist as to what is support vector machine and how does it work. Okay, so once you get a hang of the theoretical part, definitely we will see the hands-on. So you have all seen that machine learning is classified into supervised, unsupervised, and reinforcement learning. So we are focusing on supervised learning, that is, labels are provided, and once we have taught our model, the model will be able to give us the accurate result. Whether you can see the input over here is a strawberry. So when you train your model, it will provide you the correct answer. So machine learning model learns from the past input data and makes future prediction as the output. So if you can see this, we have got support vector machine, which is used for improving the accuracy of your algorithms. So we have got SVC and SVR. SVC is support vector for classification, that is support vector classifier, and SVR is support vector regressor. So you all have studied yesterday linear regression. There also you can apply SVR, support vector regression, but here we will be seeing support vector classifier. All right. So why support vector machine? So you can see over here that you have got labeled data. You can see strawberry as well as you can see apple. These two are given as an input and you train your model. Once that is done, you supply a new data and you get an output. So why not build a model which can predict an unknown data? So unknown data prediction is already done by unsupervised learning. So support vector machine comes into picture for improving the accuracy. So let's see what is SVM. SVM is a supervised learning method that looks at data and sorts it into one of the two categories. So if you see over here, you have got strawberries and apples. The data is labeled, you are training your model and you're doing the prediction. Now, this is your normal naive Bayes classification. Now, but how does this prediction work? This is the question, how this prediction works. So if you see over here, we have got your labeled data. Okay, so these represent your strawberry and these are your apples. Now what is happening is there is something called as a line, and this line is called as a decision boundary, which helps us in classifying that whatever data goes on the left hand side of the decision boundary will be strawberries, and whatever data goes on the right hand side is your apples. So this is the decision boundary. Now if you see over here, if I'm giving an unlabeled sample, okay, so I'm giving you strawberry as well as apple. So what it is going to do over here is basically it has to plot the new data, that is strawberry and apple. Now how it is going to plot on the basis of the training that has been done from the previous labeled data. But what if the amount of data that is provided is not sufficient for training the model? There is a very high possibility that the new input data could be misclassified. And we do not want apple to be recognized as strawberry and strawberry to be recognized as an apple. That is a misclassification. So in that case, we have to train our data in such a way that given the decision boundary, whatever new input data is provided, it gets correctly classified. So apples should be correctly classified as apples and strawberry should be correctly classified as a strawberry. So this is basically the main role of support vector machine, that is reducing the misclassification errors by training your data set rigorously. So I'll take an example. We are given a set of people with different heights and weights. Okay. Now we are going to consider it for male as well as for female. So we have got height and weight for males, height and weight for females. All right. So this is for female and this slide is for male. So as you can see, height values are given and weight values are given for male as well as for female. Now I will plot this. So on the x-axis, I have taken weight and on the y-axis, I have taken height and I've plotted this. So let's add a new data point and figure out if it is a male or a female. Okay. So I've taken a new data point. Now, this data point, we have to see whether it falls in male or in a female category. So what are we going to do is, we are going to draw a line. Now you can draw line in various ways. The one with blue is one of the probabilities, one of the ways of drawing the line. The red one is another way. So you can have two possibilities over here to distinct or differentiate between males and females. Now, if you see the red color line, okay, we do not have equal spacing between both the classes, males and females. All right. But if you see for blue, the blue line, you can see that the spacing on either side is equal and it is maximum. Whereas if you see over here, the spacing is not maximum on either sides. So what is the ideal line that has to be considered is the line which has got maximum space between the two data sets or data points for that matter. So out of blue and red, we will be considering the blue line. Okay. So what will happen in that case? If you can see over here, there is maximum space on either sides of this line. Okay. Now, let me take you through a few terminologies. So what will happen is this line is best splitting both the data sets of male and female. So if you see over here, this blue color line which is there is basically called as your hyperplane. Now it depends upon the dimensions. 1D, 2D, 3D and n dimension. Okay. So if it is one dimension, it is basically considered to be a line. If it is more than one dimension, if it is considered to be three dimension or n dimension, if it is three dimension, it's a plane. If it is n dimension, it is called as a hyperplane. So here in this case, this is two-dimensional data. So now if you see over here, there is maximum space on the either sides of the blue line. So that is basically called as your distance margin. The terminologies are important when we do the hands-on. Okay, so this is the distance margin. Now, because it is two dimension, this particular blue color line is called as a line. Agar three dimension rehta, then it would be called as a plane. And these points which are nearer or closer to the distance margin are called as points or support vectors. So see over here. So you have got a line. This bidirectional green color arrow is nothing but your distance margin. These points which are closer to the distance margin are called support vectors. So in technical terms, we can say that the distance between the support vector and the hyperplane, basically line, should be as far as possible. All right. Now, what we are going to do is, how do we find out, okay, the maximum distance? So whatever distance which is lying towards the positive side, the upper side of the line or hyperplane will be called as d plus. And whatever distance will be lying on the left hand side of the plane or line for this matter will be called d minus. And once that is done, what are we going to do is we are going to sum up. You can see over here. So this is d plus and this is d minus. So we are going to sum up d plus and d minus, and this is how we get the distance margin. Okay, from the support vectors. Now, once you have done that, so from the distance margin, we get the optimal hyperplane. Okay, so we have to see the distance between both the data points which are there, support vectors, should be as far as possible. Then only the hyperplane is said to be optimal for that matter. Now, based on the hyperplane, when we get a new data point, okay, so you are getting a male. Now what is happening is it belongs to male gender. So in that case, what will happen? It will belong to the male category. So the new data that you are providing will get correctly classified on the basis of the hyperplane. If suppose we took this particular line as our hyperplane, there was a possibility that the new input data would have been incorrectly classified as a female, even though it is a male. And this is what we do not want. Okay. So choosing an optimal hyperplane is very important in support vector machine. Once you have chosen an optimal hyperplane, then definitely the new input data that you are providing will get correctly classified. Okay. Have you all understood till here? Can I get a yes or a thumbs up so that I can proceed further? Okay, cool. So now this example was basically for the data points that were separated evenly. That is, it was very feasible for us after plotting to draw the line. But yeah, Pathway is asking on what basis can we choose an optimal hyperplane. The parameters for choosing an optimal hyperplane is the maximum distance between the support vectors. This. So support vectors which are there, we will try to find out the distance between these two data points, and if they are as far as possible, we will get the optimal hyperplane. Yeah, Rohan is asking, what if we get another optimal hyperplane in which the point lies in the female category? Uh, Another hyperplane in which the point lies in the female category? I didn't get you. Can you please reframe your question? D plus and D minus is basically nothing but on the basis of these points. That is the support vectors. We will try to find out the optimal distance or the largest distance. And what are we going to do is we'll take a random hyperplane and find out what is the distance of this plane with respect to the male data point and what is the maximum distance with respect to female data point. And in that case, what will happen is we will be selecting the maximum distance, and the result that you get will, which is having a maximum value, will be acting as your optimal hyperplane. Harsh is saying if the vector points overlap, that means you will, I'll come to that point. If they overlap, then what to do? I was just coming to that. You have to apply transformation. So the question of Harsh is valid. Basically, if you see over here, we could clearly use a hyperplane. There can be only one optimal hyperplane. There can be multiple hyperplanes, but optimal will be only one. What if the new input lies in the female category? Yes, I'll tell you. Yes, there will be multiple hyperplanes, but the optimal one will be only one. Cool. So now if you can see over here the data points were spaced out evenly. So we could definitely draw the line. But what if over here my data points are spaced out in an uneven manner? So you have got blue data points that are surrounded by the yellow data points. So drawing or obtaining an optimal hyperplane is not practically feasible. So for that, you have to use a kernel. So kernel is basically going to transform your input data that you're providing to a situation where you get an optimal hyperplane. So what is done over here is it will convert your one-dimensional data into two dimensions. Okay? Or two dimensions to your three dimensions. So that is what is the function of a kernel. We will be seeing what kernel is when we execute support vector machine. So now if you can see, this was 1D data. Now with the help of a kernel, we have transformed this one-dimensional data into two dimensions. Okay, so in that case, what will happen is now you can draw an optimal hyperplane which segregates the blue points with your yellow points. Getting it? So that is done with the help of a kernel. I'm not going into the math behind it, but this is how it works. Okay, I'll show you practically. So when you're converting 1D into 2D, okay, you get an optimal hyperplane. Stanley, did I answer your question with respect to this? You use a kernel. This is the hyperplane for this particular data set. We convert 1D into 2D, and how it is done is with the help of a kernel. Okay. Now see this, how to perform SVM on this type of data set. As you can see, you cannot draw a linear line to categorize or classify. So you have to basically, so if you are considering this case, this is not an optimal hyperplane. So you have to basically transform your data. And to transform your data, you will have to use kernel. So what kernel does is, this is a two-dimensional data. It is now being converted into three dimension. So basically, there is in Python, we have got an inbuilt function called as kernel function. So when you execute it, it converts or transforms depending upon the nature of the data set. So now what will happen is when you convert 2D to 3D, this is now your optimal hyperplane. Okay, so kernel transformation helps in getting the hyperplane so that the chances of misclassifying your data points are minimal. So these are some of the applications where you can use support vector machines. As you all know, data sets have got many dimensions. They are not restricted to only 1, 2, or 3 dimensions. You can have n dimensional data. Data can be sparse. So in that case, SVM plays a very important role that helps in correctly classifying by drawing an optimal hyperplane. Okay, so for sparse document vectors, SVM is used. For parameter regularization, I'll come to this. Basically, to improve the accuracy of your model, there is something called as hyperparameter tuning. So regularization is one of the hyperparameters that will help us to get an optimal hyperplane and increase the accuracy of the model. So that is hyperparameter tuning. So these are some of the advantages of SVM. Applications, once again, it is used for face detection, text and hypertext categorization. You can classify images and bioinformatics. In my hands-on session, I will be teaching you how support vector machine can be applied on Irish flower dataset. This dataset is available online. So we will be importing this dataset and applying support vector machine. Is it clear till here? Any doubts? At least you all have got a gist as to what is support vector machine. All right. Can I get a few more yes or thumbs up if you all have understood so that I can proceed with the hands-on? Perfect. So moving on to the hands-on, I'm going to do this using your Jupyter notebook. So before going on to Jupyter notebook, I'll explain to you what kind of a data set I'm taking. Basically, this is an Irish flower data set where we are going to consider 4 features, okay? That is petal length and petal height, sepal length and sepal height. Okay, so we will be considering 4 features: petal length and height, sepal length and sepal height. So if you see, if I'm considering your petal length and petal width, okay, so we have got 3 different types of flowers basically under Irish flower data set: setosa, vesicular and virginica. These are the 3 names. Okay, so when you plot it, this is a 2-dimensional plot where we have plotted petal length and petal width. So if you all will now tell me the most ideal and optimal hyperplane will be this, that is going to classify. Okay, so these are some of the possibilities of getting hyperplanes. Okay, line for that matter, because this is a 2D. Now we have to see from this which one is the optimal line for a 2-dimensional data. So what we are going to do is we are going to check the distance between the support vectors. Support vectors are nothing but the nearest points. So in that case, what are we going to do is we will be checking the distance margin. Okay, and what we find is this has got minimum distance, so the red line can be excluded. Whereas the black line shows maximum distance between the 2 support vectors. So that now this is acting as your optimal line. So these are your support vectors which help us in getting the optimal line for a 2D data. So as I told you, for 2-dimensional data, we have got a line. For 3-dimensional data, you have got a plane. So what will be it for an n-dimensional data? Can you reply on the chat? It's a line for 2D, plane for 3D. So for n dimension, what it will be? Perfect. So I'm getting the correct answers. So y'all are on the right track. It is a hyperplane. So support vector machine, it draws a hyperplane in n-dimensional space such that it maximizes the margin between the classification groups. All right. Now, you can see these 2 graphs. If you can see over here, basically, these are some hyperparameters. Okay, so if you see, this is a linear line. And here, if you observe that this particular blue data point is getting misclassified. Okay, so always it is not feasible to get a straight line. But if you see this wiggled line or a zigzag line over here, it is able to correctly classify your data. So basically, all these are hyperparameter tuning that is done. So if you keep gamma value high, you will be able to get correct classification as compared to low gamma value. I will teach you in the hands-on how to get these gamma values. Similarly, there is something called as regularization, which is a hyperparameter tuning. So here also, if you see, if it is a straight line, it is difficult to classify correctly. But if you see, if you are keeping the regularization value, which is denoted by C, okay, in SVM, this is a standard notation. If C is used, you must understand that it is a regularization parameter. So higher the value of C, better is your accuracy, and you will get correctly classified data points as compared to low value of C. Okay. Now, if you see over here, what I've done, this is a complex data set. Now, in this case, the blue points are surrounding this particular green data points. So what will happen? Getting a hyperplane for this 2D is very difficult. So we will convert this 2D into a 3D. And to convert 2D into 3D, we will be using a kernel. Okay. So what will happen? We are going to use a kernel. You can see over here, you have got x-axis. This is your y-axis, which is perpendicular. And you have got your z-axis. The y-axis is perpendicular to your monitor. That is why it is difficult to visualize. So once you have converted 2D into 3D, you can see this red line. This red line is nothing but your optimal hyperplane. Okay. So what will happen is this line, after converting 2D into 3D, we can correctly classify the data points. So this is how it will look. So this is kernel transformation basically. So this is how your hyperplane will look. Again, if I come back from 3D to 2D. All right. So for simplification, this is the 3D view and this is your 2D view. Okay. Fine. So I hope you all have understood with the background of this Irish data set what I'm going to use. Now, I request all of you all to open their Jupyter notebook. Once you have opened Jupyter notebook, you can just put a thumbs up or a yes. All right, a few more yes I can get so that I'm good to go to take hands-on on Irish flower data set. Okay, so what are we going to do is, first thing first, we are going to import pandas library as PD. So as you all know, pandas is basically used for data visualization. So we'll import pandas as PD. And once you have done that, sklearn library itself has got some of the data sets which are already present. One among them is the iris data set. So what are we going to do is, we are going to import it directly. We are not going to use any CSV file. So from sklearn.datasets, import load_iris. And this load_iris will assign it to a variable iris, and we will execute this particular cell. Y'all can simultaneously type. It would take some time for execution. So it has been successfully executed at my end. Just ping a yes or a thumbs up so that y'all are on par with me. So if you want to load your own data set, as I told you last time, you can write down pd.read underscore CSV, and you can give the link for your CSV file if you have your own personalized data set where you want to apply SVM. Okay, now we want to see what are the features in this Irish flower data set. So we will just use this command dir iris. So this will basically tell you what all features are present. So we have got feature names and file name, target. We are interested in what is the target and the target name and the data. So please execute this. Have you all done? Now within this feature names, we want to check what all features are present in this data set. So what are we going to do is we will write iris.feature underscore names. So when you do that, these are the 4 features available in your iris data set. That is sepal length, sepal width, petal length, and petal width. Have you all done till here? Okay, Sapna has done, Royce has done. A few more responses so that I can proceed. Cool. Now what are we going to do is, for better visualization, we are going to create a data frame. Okay. So how do you create a data frame is with the help of pandas. So pd.data frame, what are we interested is we want to see the iris data, this data. What all records are placed in this data set. So what are we going to do is pd.data frame iris.data. Iris is nothing but whatever value variable you have used here. So iris.data columns is iris.feature names. So basically we want to know that sepal length, sepal width, petal length and petal width में कितना data है. That is the number of rows and the number of columns. Once you do that, execute the cell. I'll paste this code if you all want on Google Meet chat so that we can save some time. Okay, Stanley wants me to scroll above. Step 2, okay. It's basically description. DIR specifies for the description what all things are included in your iris flower data set. Can I proceed? You have not executed the first cell, I suppose, from sklearn.datasets, import load underscore iris. Siddesh. Please execute every cell. Do not forget execution of the cells. So once you have executed this, you can see over here the features. Sepal length, sepal width, petal length and petal width. These are the four features. Okay. So as we have written df.head, we can see only the first 5 rows. If you want to see what is the total length of this particular data set, you can simply write tail. So you will come to know we have got approximately 150 rows, 0 to 149. Clear? So we have got 150 rows and we have got 4 columns. Okay. So this is the same thing, that is create a data frame as it is easier to visualize. So we want to see the number of rows and columns. So maximum we have got. Is there any doubt? Have I missed on something? I think I have not imported the by. I think I've imported at the later stage. Okay, good to go till here. So we know we have loaded our iris flower data set, which has got 150 rows or instances or tuples or records, and we have considered 4 features: sepal length, sepal width, petal length, and petal width. You can just ping on the chat box so that I can proceed further. Okay. Now what we have to do is we have to basically set a target variable, okay, in your Irish flower data set. Now this target variable, what will happen is it will basically tell you what is that particular flower. Okay, so we have got under this data set 3 types of flowers, that is Virginica. Then we have got the second one, that is vesicular and setosa. So under this, with the help of this data frame, no module, just check you are writing sklearn dot data sets import load underscore iris from sklearn dot data sets. Simran. Okay, so I'll proceed further. So what are we going to do next is basically we are going to introduce a column named target. Okay, so we have got over here, we have seen in the description target and target name. So the target name, target will be appended first. So we will append this column with the help of a data frame. So df target is equal to iris.target. Okay, so iris.target, we are appending this particular column and we will be seeing whether it has successfully appended or not. So you can see over here the target column has got appended on the iris data set. Is it clear till here? Okay, Lavia is saying yes. Okay. Cool. So now we have to check out in this particular target column what are the values. Okay. So from this target, we will be seeing there is target name. So let us see, this 0 doesn't make sense. We want to know what are the target names. So simply we will be writing iris.target underscore names. So please type this particular line and do the execution. So you see, we have got setosa, vesicolor, and virginica. These are the three types. Okay. Now, these are your target values. Now, we have got basically only three. Your data set may include more also. Previous step. Which one are you saying? Cell 14. Target. Okay. Data frame use करके target append करेंगे. We will append the target. And once that is done, the target is in the form of 0, 1 and 2. We want to know 0 represents which target name, 1 represents which target name, and 2 represents which target name. So for that, we are simply going to type iris.target underscore names. So हमें पता चलेगा that we 0 means setosa, 1 means vesicular, and 2 means virginica. Now we want to see that 0 occupies how many records in your data set. We have got 150 records. We want to check 0, that is your setosa is taking how many records, vesicular is taking how many records, and virginica is taking how many records. So it is very simple. Within the data frame, we will call another data frame and we will put the value 0. 0 is basically for your setosa because here 0 is setosa, 1 is vesicular, and 2 is virginica. So when you execute this particular code, you can see this target values. Okay. So this is entire 150 rows. Now we want to check 0 is occurring how many times. So basically it is 49 times. Okay. So how to check it is basically within a data frame, call a data frame and we'll execute and see. So if you see over here, basically target which is there, maximum, it starts from 0. Okay. Now if you want to know how many till what record it is there, instead of head, you just type tail. So you can see till 49 we have got your 0. Okay. Any doubts still here? Similarly, line 16. Line 16 is, are you talking about this? Stanley, are you talking about checking out which target represents which target name up to which column? Virginica, yes, is a type of flower, Irish flower. Okay. Is this the code you're asking for? I'll put it on the chat. So we can see from row 0 till 49 have got target 0. That means it belongs to Setosa. Now here instead of 0, you will simply replace it with 1. So we find out that from row 50 till your row, we'll check out till what row we have. From 50 till 99, we have got 1, and 1 means vesicular. And 2 basically is from 100 to 149, which basically means virginica. Okay. Now, this is a bit confusing, 0, 1 and 2. So from this particular target column, we want to derive the target name. So from one column, you can derive its target name by using lambda. Okay. So basically, what is the command that you have to type is, and that target can be given a new name which is called as flower name. Okay, so basically I want to know that 0 is setosa, 1 is vesicular, and 2 is virginica. So the command is basically df.target. Target is the name of the column that you have, dot apply. So we will be using the apply function. Yes, I will send the code, but pay attention. So within the apply function, you are going to call lambda, and x is either going to be 0, 1 or 2. So whatever data set you provide over here, and if the target name which is there, if it is 0, the lambda value will be 0, and ultimately the flower name will be mentioned that 0 stands for setosa. Okay, so I'll execute this code. And once I've executed this line of code, and if I want to check, you can see over here 0 shows. So from one column, we are trying to derive the target's name, okay, in the another column. And that is done with the help of lambda and apply function. I'll share the code. So now you can see over here, 0 is representing setosa. Similarly, in the tail, if you check, 2 is representing virginica. So definitely 1 is representing the other one, that is vesicular. Have you all done till here? You can just give me a thumbs up or a yes. Okay. Now we are going to do data visualization. So for data visualization, we have to use another library which is called as matplotlib. Okay. There is Seaborn, there is Bouquet. There are different libraries available for data visualization. So we are going to use matplotlib. Okay, so this is the command from matplotlib. You are going to import pyplot as PLT. So please type this command from matplotlib, import pyplot as PLT. And this is the inline statement that has to be written. Percent symbol matplotlib inline. So matplot always requires this command. Have you all imported this library, matplotlib? Okay, can I get a few more yes? Okay. Now what are we going to do is, we know there are three species, Setosa, Virginica and vesicular. So we are going to separate out these three species in three data frames. So df0, within this data frame, we will call the target equal to 0, target 1 and target 2. If there would have been more targets, then we would have included 3, 4, so on and so forth. So we are separating all the three species. That is what we have to do. If you remember the graph also when we plotted for male versus female, right? And now we will check df0.head. So now what is happening? You can see only setosas. Similarly, data frame 1.head, you can see only vesiculars. And data frame 2.head, you can see only virginicas. So we have successfully split all the three species. And now we will be doing or plotting a scatter plot. Okay. Now you can have 1D, 2D, 3D, so on and so forth. I'm going to show you how scatter plot can be done for one-dimensional data. So what I'm going to do is, under scatter function, I'm going to call sepal length and sepal width. Okay, sepal length and sepal width. So plot dot scatter, sepal length and sepal width. And I'm going to keep the color to be blue and the marker to be plus. So when you execute this, this is how your plot will look. This is one dimensional. So you have got sepal length and sepal width. Color of the plot, I've kept it as blue, and the marker that I've used is plus. Yes, I'll share the code with you all. So you can see this is a one-dimensional plot where we have considered only for setosa. df0 is setosa. We have considered, there are 4 features. We have considered only 2 features, sepal length and sepal width. Now, if I want a 2D plot to be printed, that is, I'm going to compare df0 and df1. I'll be using these two. So df0 is setosa. So setosa sepal length and sepal width. And df1, which is there, is your vesicular. So vesicular sepal length and sepal width. To distinguish both of them, I have used, the previous code is already posted in the chat, Soumya. So to differentiate between both of these, I'm going to use the color blue and red, and I'm going to use the marker as plus and dot sign. So now you can see this is a 2D plot. I'll share the code. Don't worry about the 2D plot also. So look at the graph over here. So we have got df0, that is setosa, represented with the blue color markers, and the red dots are basically for vesicular. I'll share the entire this thing for 2D so that you can save time on the chat. Once you all have done till here, please let me know. Okay, so from 1D, 2D we have done. This is not kernel transformation. I'm just showing you data representation or visualization using matplot. Now we'll add labels. So simply for this code itself, we will be putting the labels. So plt.x label, where x-axis represents the sepal length. Telsi is asking for data visualization. Okay. So basically what you're supposed to do is you are supposed to import matplotlib. Okay. And from there you're going to use the matplotlib library and you'll import pyplot. Then we know there are three features, that is 0, 1 and 2. 0 is for setosa, 1 is for vesicular and 2 is for virginica. So we will split it because we want to represent it in a graphical manner so that we can obtain an optimal hyperplane. So here you can see after splitting it, the splitting is done with the help of the data frames. We can see df0.head for setosa, df1.head for vesicular, and df2.head is for virginica. Now what I'm going to do is I'm going to plot a one-dimensional scatter. So for that I require a scatter plot where I'm only using data frame 0. So setosa का sepal length और sepal width लिया है. So this is only for setosa. df0 is setosa, not virginica. How can it give you virginica? df1 is vesicular and df2 is virginica. So I have plotted this one dimension. Then simply what I'm doing is from 1D, I'm showing you the data visualization in 2D. So data frame 0 के नीचे data frame 1 लिखा है. मैंने 0 को सिर्फ 1 से change किया है. Colors मैंने change किए हैं for distinction and I've used different markers. So this is my plot. If you can see over here, you can get the hyperplane. This line which can separate it out. So let me give axis. Axis is basically plt.x label, sepal length, x-axis, and y label is sepal width. So when I execute this, you can see the axes have been shown, sepal length and sepal width. If you require this code, I'll share the code. So once you execute this, you will be getting the x-axis and the y-axis label where you have got sepal length and sepal width. Similar manner, you can do it for petal length and petal width. So change sepal to your petal. Rest all remains the same. Let me know once done. What is the error, Soumya? You have an assignment based on this also, so make sure you are executing it correctly. There are two assignments for y'all. Both will be having different data sets. Cool. So I think most of them have done. So now what are we going to do is, we are going to basically perform training on this data set. Okay. So for that, we are basically going to use or import the train test split model. So if you all can see over here, from sklearn.model selection, okay, I'm trying to import train underscore test underscore split. So all of y'all, please type this. Now here comes the actual training part, the machine learning part. Make sure you don't miss the underscores, otherwise you may get an error. I'll paste the code on chat. Now, as you all know that we do not require target and flower names. We will have to drop those columns. Okay. So what are we going to do is, we will be using the drop function. So df.drop, we are going to drop target as well as we are going to drop flower name columns. So both the columns we are going to drop. Okay. So once you execute this cell, you can see target and flower name columns have been dropped. I'll give you this line of code too. Joel has done a few more yes, so that I can proceed. All right. So once that is done, what are we going to do is, that target column is needed for training purpose. So what have we done is, we are going to keep that target column. So it will be df.target and we will assign it to a variable y and we will see the values. So as you all can see, 0 is for Setosa and you can see till 149 it is still your Virginica. So basically we have split it into train and test. So in the training, we will be including X train and Y train. And for testing, we will have X test and Y test. So let's see what is the next step. This is very important step of your training the model. We have got 150 records and we have to train this particular data set. So what are we doing is, we are splitting this 150 records into 80-20 ratio. So 80 will be used for training and 20 will be used for your testing. We are taking the same data set for testing for a simple reason is, we do not get a biased output. Okay. So when we are taking a data set, make sure if you have got 100 records, you use 80 records for training and 20 records for testing. If you use all 100 for training and some other data you use for testing, there is a possibility that you may get misclassified response. So ideally it is recommended 80-20, 70-30, 75-25. So what are we doing is we are using the train test split function where we have got 150 entries. So X train, X test, Y train, Y test. And here we have got X and Y values, and test size is nothing but 0.2, which means it is 20%. अगर 30% बोला जाता तो you have to do 0.3. Okay, I'll share the train test split code to avoid any typing errors at your end. Once you all have done till here, we can check whether the splitting has been done properly or not. So simply use the len function. So xtrain, when you do, I think I have not executed the previous cell. Let me execute it. So you can see 150 are used for training and 30 are used for testing for X. So 120 plus 30 is 150. Perfectly, we have done 80-20 ratio. Similarly, for Y train, 120 and 30. So we have correctly split our data set in 80-20 ratio, where we will be using 80% for training, that is 120 records, and we will be using 30 records for your testing. Line 39, who is wanting line 39? I have already pasted this line of code. Leafia 41. Okay. It's nothing but you're finding the length of these individual values or parameters for that matter. Good to go? Can I get a yes or thumbs up? Okay. So ट्रेन टेस्ट हुआ है, मॉडल को ट्रेन किया है हम लोग ने 80-20 के रेशियो के हिसाब से. Now comes SVM, support vector machine. Now SVM can be imported from sklearn itself. Yes, what is Ignatius asking? We declare Y is basically we are splitting the actual results so that any unseen sample is given on the basis of the training that has been done to our data set, we can get the correct answer. Line 39. 39 is skipped. Where we declare Y. Is this the one? Okay. Can I proceed to the actual SVM part? Fine. So what are we doing is basically from sklearn.svm. So sklearn has got this SVM feature inbuilt available, the library. We are going to import SVC, support vector classifier. Okay, as I told you, for classification it is SVC. For regression it is SVR. I'm not moving to SVR. I'll stick to SVC for this session. So what will happen is we will assign this SVC to a model. And now what are we going to do? We are going to train the model. So in that case, X train and Y train will be trained using the fit function. Model.fit xtrain, ytrain. I shall paste the code if you all need any assistance. Let me know once you all have done till here. This is the line where y is declared. Okay. So with the help of fit function, we have basically trained our x and y. So if you can see over here, you must be getting SVC, that is support vector classifier. You can see C is equal to 1. If you remember in the theory, I told you C stands for regularization. So in that case, C value over here is 1. Okay, regularization. And I had also told you something about gamma. Okay, so these are hypertuning parameters. You can change these values according to your preference. I'll show you how to change. As I told you, this is kernel. Kernel is used for transformation. You just got SVC as output. You might have not executed this model.fit xtrain ytrain. Did you all get SVC with the values? Yeah, there are many students who are getting it. No problem. If you're getting gamma as auto-deprecated, don't worry. The value of gamma will keep on changing and I'll show you how. So I'll not take, these are all basically hyper parameter tuning. Okay, the parameters that can be tuned to train your model accordingly. By default, C ka value, which is regularization, is 1. Gamma value, by default, it can be auto, it can be scale. In my case, it is showing scale. Kernel is used for transformation. That is, if there is a need for your data set to be transformed from 2D to 3D or from 3D to ND, by default, kernel gets used. So you have got RBF kernel, linear kernel, so on and so forth. I'll show you how to find out which kernel you want to use. And these are some of the other parameters. Okay. Now we will check what is the accuracy of your model, the training. So it is model.score x test, y test. So when you execute this code, you get 93.33% as the accuracy of your model. Let me know once you have done till here. Okay, you may get variations, not a problem. I have ran the code several times, so I'm getting a higher accuracy. One point zero is 100%. That means your model is true correctly. Okay, so the scores might vary, but ideally it should be in the range of 90 to 100. Okay, so with this accuracy, you can basically, whichever new point you add, you can correctly. 0.69 is not an acceptable value of accuracy. You will have to retrain your model by adding some more records. Okay. So this is how SVM works. How to do that? For this library, for this data set, you can't do it. If you want, you can go to Kaggle and you can download this data set and you can add a few more records and then upload it. From sklearn, I've directly loaded this data set. So here in this case, you can't do it directly, but manually if you want, you can download the data set from Kaggle and you can upload it, and then you can perform the same process and you can increase the number of records. Okay. Now here I basically wanted to show you all how hyperparameter tuning can be done. So this is the same thing, that is from sklearn.svm, I'm importing svc, support vector classifier. And now in this classifier, I want to know how do I tune my parameters. So simply within this function, you will click on Shift Tab. So when you click on Shift Tab, you will be getting the values over here. Okay, so C ka default value which is there, it is 1.0. Kernel used is RBF. And you can see below how you can change the description of each of these parameters will be given. So if you see over here, gamma, you have got two variations, scale, auto, or float. Okay. Similarly, if you check for kernel, I'll show you for kernel. Kernel is over here. Kernel can be RBF. RBF stands for radial basis function. I'm not getting into it. It is basically for transformation only of 2D to 3D. You can have kernel as RBF. You can use kernel as poly, or you can use sigmoid. You can check it for yourself by replacing it. I'm doing it for C, which is the regularization parameter. And I'll change it for gamma also and show it to you. So basically here, I'm going to write down C is equal to, initially it was 1.0. I'm increasing it to 100 or 1000 for that matter. And once it is done, I'm again passing it for train test. I think I have not executed this. Okay. Now you can see over here, C is changed from 1 to 100. Okay. Rest all parameters are as it is. Now I'm basically using the score function. You can see it is 0.966. Initially it was 0.933. Now it is 0.966. So what does it indicate? That higher the value of C, which is the regularization parameter, more is the accuracy. Same way, you can do it for gamma. So here if you see, gamma value is scale. So I can keep gamma over here as auto for that matter. And then execute. It's giving me an error. Okay, I have to add a numerical value. So it's 100. I'll put 1000. And then try and execute. Yeah, 1.0 is correct. It means it is 100% accuracy. Because you will get it in the range of 0 to 1. So here if you see, I have not changed C. I have changed my gamma from scale to your 1000. Okay. And now what happens is, see, I'm getting 0.3. So when my gamma value, which is there, when I'm changing from 1000, okay, if I reduce the value, maybe if I'm keeping it is just 10 and then checking, let me see if my accuracy is getting affected. So from 0.3, I got 1.0. So what does it imply? Lower is the value of gamma, better is the accuracy. Similarly for kernel, initially kernel was RBF, I'm changing it to linear. So what is happening? So C value is 1. Gamma by default it is scale. Kernel now from RBF I've changed it to linear. So now when I check the accuracy, it is 1.0. So what does it indicate? When I'm using higher value of regularization, I'm getting more accuracy. When I'm using a linear kernel, I'm getting more accuracy. When I'm using lower value of gamma, I'm getting more accuracy. You can play around with the parameters for getting an optimal hyperplane. Have you all understood till here? Can I get a yes or thumbs up? Okay, so this is how support vector machine works. So with this, I conclude the session from my end. If there are any more queries, you can definitely ask me. I hope you all enjoyed the session and you all are thorough with Gaussian naive Bayes and support vector machine. Yes, we basically don't use the word fool, but we manipulate. Manipulate is the more technical term. So you can manipulate the output to improve accuracy. That can be done. So the technical term you can say we manipulate. That can be done. Sir, even by changing the train test data, we get a good result. So I changed my data, yes. So higher, more records, you are keeping it in 80-20 ratio or 70-30 ratio, you get good results. So how will we know how much do we train and test? See, there is no fixed ratio, but what is recommended is always 80-20, 70-30, 90-10. So you can play around with the train and test size. Okay, thank you, Soumya, for your comment.
I will request the students that if you have any doubts or queries regarding the session as sir is concluding, if you have any doubts, you can just ask sir, or you can put it in the chat box.
Yeah, I'll just put one point of instruction. The assignment what I've given is completely based on Gaussian knife base and SVM. For Gaussian knife base, you have to use the tennis data set, and that data set is available on Google Drive. When you click on the link, you can download the data set. And for SVM, you have to use the digits data set. So how you are going to import that digits data set, I have given the hint in the assignment, which will be uploaded by your respective faculty.
Okay, as there are no other questions in chat box. Vivian sir?
No, I don't find any questions, ma'am. They are asking whether I'm going to take tomorrow also. No, I'm not taking the session for tomorrow. There's some other person who will be taking.
Okay, so now here there are some important instructions.
What if the data is not clean? Then we will have to pre-process the data. Whichever cells are blank, you will have to put some value. You cannot keep null. You cannot use a blank data set. It will pre-processing is a must. So that will have to be done. So I think I've answered all the questions in the chat, Priyanka ma'am.
Yeah, okay.
So I think I'll conclude from my end.
Okay, I request all the students to please wait. There are some important instructions to you all. And before that, I'd like to thank Vivian sir that it was really a wonderful session, and I'm pretty sure that participants have understood the classification using Gaussian naive Bayes and support vector machine, the concepts also through your PPTs, and also the implementation part very well. And this session will really help them for their future for doing projects if they have any interest or they want to explore more in this particular area. This is really going to help them. So I thank you once again for this wonderful session and the efforts taken by you to for this
Thank
entire
you,
session.
ma'am. I would like to thank Department of Information Technology for giving the opportunity to have you all and take this session, especially the convener, Dr. Joanne Gomes, and the coordinators, Dr. Nazneen Ansari and Web of Kala sir, and all of you all for inviting me and sharing my knowledge with the students.
Yeah, I thank you. I thank you, sir, for accepting our request and giving this wonderful session. Now, for students, there are some instructions that every day we are having some assignments. So, day one, assignment one, though some students have joined late, the deadline for submission is extended till today 10 p.m. Okay, so please make note of it. Till today 10 p.m. you can submit assignment 1. Assignment 2 you can submit till today 6 p.m. Okay, assignment 2, the deadline is today 6 p.m. and we have WhatsApp group and we have Google Classroom. Okay, so you are expected to join both the places. In the chat box, I have shared the Google Classroom class code, and also I have shared the today's sessions feedback form link. So kindly submit that feedback also. Please remember that feedback form and the assignment, okay, daily feedback form and daily assignment are mandatory for all the students, because with that your attendance is going to be recorded. Okay, and by considering the attendance of all the sessions, you will be considered for certification. So for attendance, what you have to do is, one is assignment and next is, second is feedback form for everyday session. So if you have missed out anything, you can ask the teachers through the WhatsApp group, but make sure you complete all these things. All the assignments you are supposed to submit on the Google Classroom. The related materials and questions and everything will be provided on Google Classroom. So kindly go through that, and this Google Classroom code and the feedback form link I have shared on the chat box. So please check that and go through it. If you have any queries, you can put in the chat box. Otherwise, we will end this session. Today's sessions assignment and the contents that are taken by Vivian sir, the PPT and the different hands-on and the assignment, everything will be uploaded at 2 p.m. today on Google Classroom. And submission time of today's assignment, okay, day 3 assignment submission is till tomorrow morning 10 a.m. Tomorrow morning 10 a.m. Okay, so make note of all these things and make sure that you don't miss out any assignment submission. I think there are no other questions, so I'll request everyone to once again fill this feedback form. Okay, and tomorrow join for the next session that will be at 9:50 a.m. Okay, I will now request everyone to leave this meeting.